let's talk about something that sounds like it's straight out of a sci-fi movie, but is actually an idea that's over 100 years old. We're talking about sending electricity, actual usable power, right through the air. No wires, no plugs, just energy.
I mean, seriously, just think about that for a second. We've got wireless internet, wireless music, but our devices are still chained to the wall with charging cables. What if that last cord could finally, truly be cut?
So this isn't some brand new idea. We're actually diving into a fascinating physics project that does exactly this. It takes the legendary Nikola Tesla's huge vision for wireless power and proves that it works, but on a really small, understandable scale.
And the goal here? I love this. It's so refreshingly straightforward. No crazy scientific language, just a very clear mission. Build a small, working model that can send electrical energy from one point to another through the air. That's it. It's all about proving a revolutionary idea with pretty basic parts.
And this quote just nails it. This whole thing isn't just some fun history lesson. As the project itself points out, Tesla's idea from way back in the 19th century is actually the bedrock of the wireless world we all live in and depend on today.
Okay, so it sounds like magic, right? Power just zipping through the air. But how does it actually work? Well, it might seem complicated, but the science behind it is surprisingly elegant. So let's pull back the curtain. It all boils down to this one key thing, a magnetic field. The best way to think about it is like an invisible energy bridge. The circuit isn't shooting a tiny bolt of lightning across the room. Nope, it's creating this energy field all around it, and that field is what carries the power from the transmitter over to the receiver. And check this out. Here's how it happens step by step. First, the circuit starts humming along, creating these super high-frequency vibrations. That energy gets pumped into the first coil, which generates that magnetic field we were just talking about. That field then expands and causes the electrons in a second nearby coil to start moving. And boom, just like that, a little bulb or an LED connected to that second coil lights right up. No physical connection whatsoever. Okay, so we've covered the what and the how. Now for the really fun part. What does it actually take to build one of these things? Let's take a look at the shopping list and see how you go from a big idea to a bunch of real physical parts.
And get this, the grand total? 1,400 Indian rupees. To put that in perspective for you, we are talking less than 20 US dollars. This is a multi-million-dollar lab experiment. This is something you could build on a weekend with a hobbyist's budget. That's just incredible.
And when you look at the actual parts list, it gets even better. There's nothing exotic here, nothing you can't find easily. We're talking copper wire, a piece of PVC pipe, a simple transistor, a little wooden base. It's just a powerful reminder that sometimes the most game-changing ideas can be demonstrated with the most ordinary materials.
So let's step back for a second. Why does a little project like this, something you can build on a tabletop, even matter? Well, because it's a real, working link to a vision that could completely change our future. Because really, this is the whole story. You've got this huge, world-changing idea dreamed up by one of history's most brilliant minds, Nikola Tesla. And now, today, it can be brought to life using simple parts you could order online for less than the price of a movie ticket. It makes the whole concept real and accessible to a brand new generation. And that's the big question this leaves us with, isn't it? If this is possible on such a small scale with such basic components, what does the future look like when this tech gets bigger and better? Could you charge your phone just by having it in your pocket? Could an electric car power up while it's just driving down the highway? The possibilities are absolutely huge, maybe just as big as Tesla dreamed they would be.